In this section we are going to talk about network access, and we are going to define how we can access to a network briefly. First, we are going to take a look to physical layer overview of OSI. Then we are going to talk about network media, and lastly we are going to talk about data link layer protocols and media access control. In this lecture, firstly, we are going to focus on OSI layer 1 physical layer. In the 7-layer OSI module of computer networking, the physical layer or layer 1 is the first and the lowest layer. The physical layer consists of electronic circuit transmission technologies of a network. It is a fundamental layer underlying the higher level functions in a network. The physical layer defines the means of transmitting raw bits rather than logical data packets over a physical data link connection network nodes. The bit stream may be grouped into code words or symbols and converted to a physical signal that is transmitted over a transmission medium. The physical layer provides electrical, mechanical, and procedural interface to the transmission medium. And here are the fundamentals of the physical layer. We have three medias. The first media is copper cable, the second media is fiber optic cable, and the third is the wireless media. In a copper cable media, the physical components are maybe a UTP cable, coaxial cable, we have some connectors, we have network interface cards, ports, interfaces, and etc. In a fiber optic cable media, we have single multimode fibers, connectors again, network interface cards, interfaces, lasers and LEDs, and photoreceptors. And in a wireless media, our physical components are maybe access points, maybe again network interface cards, which are the wireless network interface cards this time, maybe radios and the antennas. Bandwidth is the bit rate of available or consumed information capacity expressed typically in metric multiples of bits per second. For example, an internet connection with a larger bandwidth can move a set amount of data much faster than an internet connection with a lower bandwidth. Here, as you can see, the abbreviations as well. If you want to talk about the kilobits per second, we are using kbps. If you want to talk about the megabit per second, we are using mbps. If you want to talk about the gigabit per second, we are using the gbps. Let's move forward with the network media. Network media refers to the communication channels used to interconnect nodes in a computer network. Typical examples of network media include copper, coaxial cable, copper twisted pair cable, and fiber optic cables used in wired networks, and radio waves used in wireless data communication networks. Let's go ahead with the UTP cable first. Unshielded twisted pair UTP is a type of copper cabling used in telephone wiring and the local area networks. Inside a UTP cable is up to 4 twisted pairs, as you can see in here. Here, as you can see, the pairs are twisted to each other. And we have enclosed in a protective plastic cover with the greater number of pairs corresponding to more bandwidth. The two individual wires in a single pair are twisted around each other, and then the pairs are twisted around each other as well. This done to reduce crosstalk and electromagnetic interference each of which can degrade network performance. Each signal on a twisted pair requires both wires. And here are the standards when we are using the UTP cabling. UTP categories are starting with the Cat 1 and finishing with the Cat 7. We have various data rates for each categories, as you can see. For example, if you are using Cat 1, you can use up to 1 megabit per second, but if you are using Cat 7 cable, you can use up to 10 gigabit per second data rate. The maximum lengths are almost the same, as you can see. It's almost 100 meters. And the applications that are using the different categories are, for example, Cat 1 is used in all telephone cables. Cat 2 is used in the token ring networks. For example, Cat 6 is being used in gigabit and 10 gigabit Ethernet networks. Let's go ahead with the UTP connectors. Connector is the part of a cable that plugs into a port or interface to connect one device to another. Most connectors are either male, containing one or more exposed pins, or female, containing holes in which the male connector can be inserted. The RJ45 connector is an 8-wire connector that is commonly used to connect networking devices such as switches, routers, or PCs to a local area network. This connector is used with Cat 5 or Cat 6 cables commonly and consists of 8 pins. Here is the male connector, and here, as you can see, this is a female connector. Let's go ahead with the UTP cable types. T568A and T568B are the two color codes used for wiring 8-position RJ45 modular plugs. The only difference between the two color codes is that the orange and the green pairs are interchanged. Straight-through cable is a type of Cat 5 which the RJ45 connectors at each end have the same pinout. Color code used on both ends are the same. Straight-through cable is also referred as a patch cable. Straight-through cable is used to connect computers and other end-user devices to networking devices such as hubs and switches. And a crossover cable is a type of Cat where the one end is T568A and configuration and the other end is T568B configuration. Pin 1 is crossed with pin 3 and pin 2 is crossed with pin 6. Crossover cable is used to connect two same devices, for example, router to router connection. Here, as you can see, the T568 pinouts, and as you can see, we have 8 pins in here. If you are using this pinout with T568A, in the first pin, you are using white-green cable, in the second you are using green, third white-orange, blue, white-blue, orange, white-brown, and brown. If you are using T568B, in the first pin you are using white-orange cable this time, then orange, white-green, blue, white-blue, green, and white-brown, and the brown. Let's go ahead with the shielded twisted pair cable. Shielded twisted pair is a special kind of copper cable used in telephone or local area network systems. An outer covering shield, this guy, is added to the ordinary twisted pair wires, to prevent electromagnetic interference, and the shield functions as a ground in here. Coaxial cable is a type of copper cable specially built with a metal shield and other components engineered to block signal interference. It is primarily used by the cable TV companies to connect their satellite antenna facilities to customer homes and business. Some homes and offices use coaxial cable too in their local area network, but its widespread use as an Ethernet connectivity medium in enterprises and data centers has been supplanted by the deployment of twisted pair cable. A fiber optic cable is a network cable that contains strands of glass fibers inside an insulating casing. They are designed for long distance, very high performance data networking and telecommunications. Compared to wired cables, fiber optic cables provide higher bandwidth and can transmit data over longer distances. The two primary types of fiber cables are called single mode and the multi-mode fiber. Single mode fiber uses very thin glass strands and a laser to generate light, while multi-mode fibers use LEDs. Single mode fiber networks often use wave division multiplexing techniques to increase the amount of data traffic can be sent across the strand. As I told you, multi-mode fibers use LED as light source and provide multiple paths for light. If we compare with the single mode, they provide lower bandwidth and higher attenuation. And here are the connection types that we can use in the fiber optic cables. We have LC connector, SC connector, ST connector, FC connector, NTRJ, MU and E2000 connector types. And let's compare the fiber optic with the copper cable. As you can see in here, let's take a look to the distance. Optical fiber can provide up to 12 miles, while copper provides communication up to 300 feet. The width is almost 4 lbs in here, while the copper is 39. The maximum bandwidth that optical fiber can provide 69 terabit per second, which is much higher than the 10 gigabit per second. But optical fiber is hard to tap and easy to alarm, but copper emits the EMI, electromagnetic interface. Let's go ahead with the wireless communication. Wireless communication is the transfer of information between two or more points that are not connected by a cable. The most common wireless technologies use radio waves. With radio waves, speeds may be low as 3 megabit per second for Bluetooth, for example, or maybe really high up to 1 gigabit per second for the WiMAX technology. And let's take a look to 802.11 Wi-Fi standards. These standards are set of media access control and physical layer specifications for implementing wireless local area network communication. In the chart, you can see the evolution of the standards. In the first standard, which is .11, maximum data rate is 2 megabit per second. But in the .11 AC standard, which is the latest standard, the maximum data rate is 7 gigabit per second. And in here you can see the frequency bands, bandwidths, modulation types, and advanced antenna technologies for each standard as well. Let's go ahead with the data link layer protocols and media access control now. The data link layer, or layer 2 of OSI, is the second layer of the 7-layer OSI module of computer networking and provides access to media via MAC addresses, guys. This layer is the protocol layer that transfers data between adjacent network nodes. The data link layer provides the functional and procedural means to transfer data between network entities and might provide the means to detect and possibly correct errors that may occur in the physical layer. Protocols like Ethernet, PPP, and HDLC operate at this layer. The most important standards used in layer 2 are Ethernet, for example WiMAX, Bluetooth, which are created by IEEE, ADSL, and MPLS, which are created by ITU-T, and we have HDLC and MAC, which are created by ISO, and we have FTDI, which is created by ANSI. These are the most important ones. The data link layer functionality is usually split into two logical sub-layers. As you can see, we have logical link control and media access control. The upper sublayer, termed as LLC, logical link control, that interacts with the network layer above, and the lower sublayer, termed as MAC, media access control, is the one that interacts with the physical layer below. While LLC is responsible for handling multiple layer 3 protocols like multiplexing and demultiplexing, and the link services like reliability and flow control, the MAC is responsible for framing and the media access control for broadcast media. Ethernet is the most widely installed local area network technology, guys. Ethernet is a protocol in the describing how network devices can format data for transmission to other network devices on the same network segment, and how to put the data out of network connection. Ethernet defines two units of transmission: packet and frame. The frame includes not just the payload of data being transmitted, but also addressing information identifying the physical media access control MAC addresses of both sender and receiver. VLAN tagging and quality of service information and error correction information to detect problems in transmission. Each frame is wrapped in a packet which affixes several bytes of information used in establishing the connection and marking where the frame starts. Another protocol used in the data link layer is the point-to-point protocol. Point-to-point protocol is a layer 2 communications protocol used to establish a direct connection between two nodes. We can use in here, for example, these devices are routers, for example. It connects two routers directly without any host or any other networking device in between. It can provide connection authentication, transmission encryption, and the compression. And lastly, we are going to focus on the topologies. So what is a topology? A network topology is the arrangement of a network including its nodes and connecting lines. There are two ways of defining network geometry, and they are the physical topology and the logical topology. Here we are seeing a physical topology. Physical topology is the placement of the various components of a network, including device location and the cable installation. Here we can see a physical topology, and what we are seeing is just the cable connections and name and symbols of the devices, as you can see. For example, we have an Apple iMac connected to gigabit switch. We have an iPad which is connected to Apple AirPort Extreme. We have an iPhone also connected to Apple AirPort Extreme, and we have TiVo Premiere which are connected to our gigabit switch. We have a printer in here which is connected to gigabit switch, and etc. That's the physical view of the topology. We have three types of physical local area network topologies, and they are ring, bus, and the star. In the ring network topology, the workstations are connected in a closed loop configuration, as you can see in here. Other pairs of the workstations are indirectly connected, the data passing through one or more intermediate nodes. For example, let's say that here is the PC1 wants to communicate with the PC2. Here is the direction of the data packets. PC1 is going to this guy, then this guy, and this guy. But what if this guy fails? If this guy fails, if there's an interruption on this guy, you can send the packet also from this way on the ring topology. In the bus network topology, every workstation is connected to a main cable called the bus. Therefore, in effect, each workstation is directly connected to every other workstation in the network, as you can see. In the star topology, there's a central computer or server, this guy, to which all the workstations are directly connected. Every workstation is indirectly connected to every other through the central computer. Here, for example, if this PC1 wants to communicate with the PC2, that should send the packet to this guy, and this guy should forward the packet to PC2. Okay, that seems like good, but if there's a problem on the central device, all the devices will fail, as you can see. And here are the physical wide area network technologies. Point-to-point topology is the first one. That's the simplest topology with a dedicated link between two endpoints, as you can see. The second one is hub and spoke topology. Hub and spoke here. In a hub and spoke wide area network topology, one physical site acts as the hub, while other physical sites acts as the spoke. Spoke sites are connected to each other via hub, as you can see in here. And in hub and spoke wide area network topology, the network communication between two spokes always travel through the hub. And here is the lastly we are going to focus on full mesh topology. Full mesh topology connects each node to all other cluster nodes. This topology is highly reliable and fast, but it does not scale well. It is reliable because it provides many paths through the fabric in case of cable or node failure. It is fast with low latency because you can get to any node in the fabric in just one hop. It does not scale well because each additional node increases the number of fabric links and switch ports exponentially. As you can see in here, for example, we have router 1, router 3, router 3, 4 and 5, and they are connected each other, and that provides really big reliability in this network. There's a really big redundancy. For example, if router 1 wants to communicate with router 2, this path can be used, this path can be used, or this path can be used. We have various ways, as you can see. So that means no matter if this link fails, the traffic will go through from here, or something like that. And lastly, we are going to talk about the logical topology. Logical topology is the arrangement of devices on a computer network and how they communicate with another. Logical topologies describe how signal acts on the network. In a logical topology, we can see IP addresses, as you can see in here. We can see tunnel types, we can see subnet mask, and something like that. That's the logical view of the topology.